Today we are going to be looking at functions. So let's start off with the definition of a function. A function is a special relationship where every input, which is your x, has a single output, which is your y. So every x has a single y. So let's go through some examples and determine if each one is a function. The first ones we're going to look at as a relation shown as a table. So the trick here and the hint is your x values cannot repeat. If they repeat, then that means it's not a function. So let's look at our first one here. We have -2, 2, 0, 3, 1, -1, and 2, 4. Since every x here has exactly one y, this is a function. So every x has one y. Let's look at this table here. You have -3, -2, -1, 2, -1, 1, and 2, -3. We have two x's that are -1. So -1 has a y of a 2 and a y of a 1. So that is not a function. -1 has two y values. So now let's look at a mapping diagram. We have -2 gets mapped to 2, 0 gets mapped to 3, 1 gets mapped to -1, and 2 gets mapped to 4. The key here is every x gets mapped to only one y. So this mapping diagram shows that every x gets mapped to one y. So that makes this a function. Each x gets mapped to one y. Now let's look at the next example. We have -3 gets mapped to -2, -1 gets mapped to 2, and it gets mapped to 1. 2 gets mapped to -3. We have this -1 being mapped to two different y's, so that is not a function. So -1 gets mapped to 2 and 1, so that is not a function. So the last examples we're going to look at are graphs. The nice thing about graphs is we can do a vertical line test to see if they are a function. So a vertical line test is just drawing straight up and down lines, and if more than one point or the line touches that line more than once, then it's not a function. So let's look at this first example. If we draw a vertical line down, we hit 2 points in this line right here. So since we hit 2 points, it's not a function. And we use a vertical line test for this one. Let's look at these points. Let's draw straight vertical lines up and down. And there is only 1 point per line there, so it is a function. And it passes the vertical line test. Let's look at a graph now. Let's just draw our lines. It passes there, it passes there, but once we get over here, it hits this line twice. I know my line's not perfectly straight, but no matter where you hit over here, it would hit more than once. So this one again is not a function. And then the last one, vertical line test, going straight up and down. And it passes the vertical line test, so it makes it a function. So now let's look at functions dealing with equations. So an equation can be written as a y equals or as a function notation, which it changes the y to this symbol, which is our function notation. And we say this is pronounced as f of x. So whatever letter's on the outside is that letter. So in this case, it's f. The parentheses is of, and then whatever is on the inside. So x. So f of x equals the same thing, 3x minus 4. When we're dealing with functions, we're going to be seeing f of x more often than we're seeing y equals, but it is the same thing. So these problems we are evaluating. We have two different functions. We have an f of x function, which is 3x minus 4, and a g of x function, which is 2x squared minus 3x. So we need to evaluate it. So number one says we have f of 2. So all that means is whatever is in the inside of the parentheses gets substituted in for x. So we have our function. Since it's dealing with the f function, we're using the first equation. So f of 2 is equal to 3. Instead of x, we put 2 minus 4. Same thing that was given, but we're just substituting 2 in for every x that we see. And then we simplify. 3 times 2 gives us 6. We bring down the minus 4. 6 minus 4 is 2. So f of 2 equals 2. Number 2, we are using the g function because it says g of negative 4. So we're going to use the second one. So we have g of negative 4 is equal to 2 times x squared, but x is negative 4, squared minus 3 times x, which is negative 4. Every time we saw an x, we substituted a negative 4. Now we need to simplify. PEMDAS says we need to take care of the exponent first. So negative 4 squared, negative and a negative make a positive, so we are positive 16. Rewrite everything else as is. Now we have to multiply before we subtract. So 2 times 16 is 32. 3 times negative 4, or you can think of it as negative 3 times negative 4. Negative 3 times negative 4 is a positive 12. Now we add 32 plus 12 is 44. So g of negative 4 is 44. Let's look at the next one. So 3, it states that we're doing the function f, which let's rewrite the function f. So f of x equals 3x minus 4. But instead of x, we're replacing it with 2x. So let's solve that. So f of 2x equals 3. Instead of x, we have 2x minus 4. And we just simplify. 3 times 2x, 3 times 2 is 6, but we're multiplying with the x. Bring down minus 4. We cannot simplify this any further because we just have an x. So we just bring down our function f of 2x, and that equals 6x minus 4. Number 4, we are dealing with the g function. So let's rewrite the g function. So g of x is equal to 2x squared minus 3x. So this says we have g of negative 1. We're going to solve that and then just add 5 to the end of it. So substitute negative 1 every time you see x. So g of negative 1 plus 5 is equal to, take our g function and just substitute negative 1 in for x. So 2 times negative 1 squared minus 3 times negative 1. And then we just add on the plus 5. And we simplify. Negative 1 squared is a positive 1. Bring down everything else. 2 times 1 is 2. Negative 3 times negative 1 is a positive 3. Bring down the plus 5. 2 plus 3 is 5. So we have the problem 5 plus 5, and that is 10. So g of negative 1 plus 5 is equal to 10. The last problem here, we have f of negative 1 plus 5. So let's rewrite our f function. So f of x is equal to 3x minus 4. So we're going to do it the same way that we did the last problem. We're going to take the f function, substitute in negative 1, and then just add 5 to it. So we have 3x, but 3 times negative 1 minus 4, and then we just add on our 5. 3 times negative 1 is negative 3 minus 4 plus 5. Negative 3 minus 4 is negative 7. Then we add 5 to it, and we get a negative 2 as our answer. So f of negative 1 plus 5 gives us negative 2. So that is it for functions. Please reach out if you have any questions.